Hello students, welcome to the IMS GATE Academy. Now let's continue the foundation course on operating system. The last two sessions we have seen foundation, like fundamentals of operating system. The last class we have started. What are the hardware support required to implement the multi-programmed operating system we have started? Yes or no? So now let's continue, and also so we'll see the system calls. What is the purpose of the system call, and also we are looking into the case study and fork system call. In the thumbnail the system call is the headline is there, but few topics, few things left over from the last session. Let's continue. We'll complete the last part, then we'll look into the system calls, the various system calls, and also we'll see as a case study on the fork system call. Very good evening, very good evening. Yeah. So what was the last class discussion? Can you recall? So what we were discussing in the last class? Hardware support. So I mentioned a hardware support required for multi-programmed operating system. I mentioned what are the support required? Can you tell me? One is address translation. One is address translation. Yes or no? Address translation. Yes. Can you give it? What other things? The second one is what? DMA support also essential. And third one is at least two modes of CPU operation. Yes or no? So these things I mentioned. Yes, is it clear? Look at, so one by one we'll see. So what is this address translation is saying? Let us understand here the first one. The first one is the address translation. So what this address translation is required? So please understand, address translation, that is logical address to the physical address need to be translated. What does mean? This please observe. So now under multi-programming environment, what we are talking? We are talking more programs, more than one program we want to keep into main memory, so we can make the processor as much as busyness, so that throughput of the system going to be increases. In order to keep the multi-programs in a main memory, we do the partitioning. So the memory management techniques, various things we can observe when it is time comes. Now right now understand, when you keep several programs, okay, sometimes some programs need to be swapped out. Sometimes we have to deal with large program size also. So to handle this all the things we need address translation. So logical to physical address translation. So what is the logical and physical address? Better this thing you will come to know when we start memory management. What is meant by logical address, why is required to be translated from logical to physical address. All the things will comes from the memory management only. We'll discuss that, ma'am. So what I'm trying to say briefly here, so if we want to design this multi-programmed operating system, this translation also required. Means we may going to deal with a large data. So large data means large program sizes, maybe the program size may be behind the physical memory, so we want to take the advantage of the virtual memory concept. You might have heard virtual memory. So when we want again virtual memory implementation, again required the address translation, logical to physical address, because our program sizes are more than the physical memory size, main memory size. So the remaining part we can keep into main memory, secondary memory, then we can move here and there. So for this purpose we cannot fix the address of the program. So we say the relative address only we given to the processor. So the relative address or logical address need to be translated into original or actual or absolute address of a main memory. So what I am trying to say here, so under such environment, so processor generates address to fetch instruction. So this address we call as a logical address. Okay, getting my point. This address, logical address or relative address we can tell. Now in a main memory, so this is a main memory. So in a main memory, we might have loaded somewhere our programs. So we might have loaded our program somewhere. Let's take this is a address. So this address is the original or absolute address. So this address we are not given to the processor. This address is not given to the processor. Now this logical or relative address need to be translate. So with the help of some hardware support, let's take the hardware is nothing but memory management unit. Memory management unit. So this will translate this logical address into the physical address. The physical address also known to be absolute address. So this is absolute address of the program which is stored in a main memory. Now this memory management unit implementation may goes like, if I use paging concept, so paging, if I use page table, through page table we can convert the logical address to physical address. If we use the segmentation, so through segmentation table, segmented table, by using segmented table we can translate the logical address into physical address. What is the logical address means? Suppose let's take example. Here is saying that suppose program is there. The program is started storing it at 100 address onwards assumption. But originally this program is stored in the main memory. So main memory, let's take 500 address onwards. 500 address onwards. Now see, original address of the program started from 500, but CPU has address at 100 only. Now see, this 100 need to be translated. 100 need to be translated into 500. Okay. So somehow you have to translate 100 into 500. Now I can say 500 is the relative address to 100. How much relative, sir? If I add 400 to this 100, so it will become 500 only. So this will be a relative address to this one. So the relative address need to be translated to original address. Sir, you can ask me question, sir, why you are giving 100 to the processor? You can give a address directly 500 only. So don't give 100, right? You can ask a question, right? Why we are giving a address of your program 100 to the CPU? Instead of that, you can give directly 500 only. So that also some challenges will be there. Why we need to give it? All the detailed things can be addressed when we take the memory management concept now. Just understand the briefly the hardware support. What is the hardware support? Here to translate this logical to physical address, this is required. That's what I want to say. One aspect in the memory also required from hardware support, so that I can effectively use the multi-program operating system. Is it clear? So just let me know if you have a doubt. Yes. Yes, just respond. So did you understand what is my intuition, what I am trying to say here? So detailed things will let us observe when we discuss the memory part, but just briefly I am giving this is support of the architecture required to be translated. Clear? Respond. So now next second one, what I am trying to say, second one, the second one is the DMA support. Okay, DMA support. So DMA support for what? IO operation. IO nothing but memory transfers. Naturally, please observe here. So this is a memory. So this is a memory. Okay. Now here is a disk. Here is a disk. Okay. Disk. Okay. Disk. Observe now. Here is a processor. Okay. Processor. Please observe. This is what main memory I am talking. Main memory, some system bus is there. Now suppose whenever you want to transfer the data from memory to disk or disk to memory. So CPU intervention generally required. Now, so processor will fetch some instruction, IO related instruction to fetch to read the data and transfer. Okay. Now processor generally do the IO operations only. Okay. Now please understand. When you are deal with a bulk data transmission, so separate chip is required to be transferred the data from disk to memory and vice versa. So that what happens, IO operation is going to speed up nothing but IO operation time will be IO time will be reduces. For the multi-program environment, whenever you want to implement the concept of virtual memory, runtime data or instruction need to be fetched from not only from main memory, you have to fetch from secondary memory. Generally processor, if you give a processor to fetch a data or instruction from secondary memory to main memory and given to the CPU by the processor, it will take more time. Instead of that, separate component, hardware component which is used to transfer the data from disk to memory, runtime only, please understand. So in this case what happens, memory IO access time going to be reduces. So this activity is managed by separate chip is called DMA controller. Most of the contemporary all architectures supporting DMA only. Instead of normal interface, we use a DMA interface to transfer the data. So that now please understand, the CPU activity, IO activity can be done parallelly. Is it clear? Is it clear? Now if I use a DMA, we are directly transferring the data through DMA only. So now we are trying to bypass the CPU. If I use a DMA, we are going to bypass the CPU for transmission of the data between these components. Clear? Clear? So DMA controller, this hardware chip is not going to be execute any kind of instruction. It is only simply used for transferring the data between these devices. Clear? The point is clear? This is essential component required for multi-program operating system. You will definitely realize when we discuss the virtual memory concept, importance of the DMA. Importance of the DMA you will realize. So that moment suppose situation comes, sir, if I want to read runtime data from secondary memory given to the processor to execute, sir, there is more time required to complete the program. How we can deal with this, sir? Such situation, the DMA is going to help a lot. So DMA will transfer the data very speed rate, so that so total execution time of program will not going to be increase. Yes, are you getting my point? What I am trying to say. This another aspect of support, required from the hardware, that's supporting of DMA. Now, so the third one is a crucial, very important point. So what is the third one? I am saying that. So if you are designing with a multi-programmer or a multi-user, multitasking or whatever types of operating system you want to design, the CPU should operate in at least in two modes, at least two modes of CPU operation. What I am trying to say, if you want to design multi-programmed, multi-user, multitasking operating system, the CPU should operate at least two modes. It can be more, but minimum two modes of operation required. So what these two modes of operation you are talking, sir? Please observe, the two modes of the CPU operation is, one mode is what? Kernel mode we call. So first one I'll write user. One mode we call user mode. Getting my point? The second mode of CPU operation is what? In a kernel mode. So kernel mode. Please observe kernel mode. This user mode is also known to be like non-atomic mode. Or we can say non-privileged mode. So non-privileged mode we can tell. Clear? Are you getting my point? User mode or non-atomic or non-privileged, non-supervisory. So it's not system mode also we can tell. So now other thing, kernel mode is also known to be, so we can call system mode. So we can call system mode, or simply we can call atomic mode also we can tell. So atomic mode, getting atomic mode, or we can call privileged mode also. We can call privileged mode also. Clear? So just note of it. All of you, please note of it. What I am trying to say, in order to implementation of the multi-programmed operating system, the CPU should operate at least into two modes. One is user, other is kernel mode. User mode is also known to be so non-privileged, non-atomic, so non-supervisory mode we can tell. Kernel mode is also known to be kernel mode or system mode, privileged mode, atomic mode, or supervisory mode also we can tell. Sir, what this differentiation, what to understand about these two modes, we'll observe clearly. Look the statement clearly, ma. I'll be writing also, you observe. So now understand, operating system is a software, right? Set of programs will be there, right? Yes or no? The moment system you turn on, some OS, whenever operating system is loaded in from secondary memory to RAM space, it's just get activated, it start working. Means some programs of the operating system started working, executing only. So that it will also help. So those programs will help us to run the user applications or user programs. Background they will run. So user programs also will run, kernel OS programs also will run. Yes or no? OS code will run, parallelly user programs also will run. Now both the codes are running here. No, operating system is what? Code, like now. So we must protect, please observe. Operating system code or operating system programs, we must protect. Protect means what? Our user programs should not interfere with the OS code. If it is interfered, that may corrupt the code. If they may corrupt the code, you understand that is now system is get crashed. Crash nothing but that is end of the system. Means OS is going to be corrupted or not? OS is going to be corrupted. Please understand now, to protect the operating system code from the erroneous users. So this should run in protected mode only. Operating system code should run protected mode only. So again I said, operating system is a service provider, right? So there are many service programs from the operating system should run protected mode. The protected mode is nothing but kernel mode. Kernel mode or system mode, privileged mode, atomic mode we can tell. So what is the purpose of this one? OS code has to run. So why should run, sir, here? Because nobody should interfere when OS code is running. If they interfere, they may modify the code. If they modify the code, operating system get crashed. So you have to avoid this all the things. This should be run in a protected mode. I hope the statement is clear. I hope this statement is clear. Now I am writing about these things. Now I am writing about this thing. So look at the first one. What is the first one? User mode. So right, user mode, I said user mode. Okay, observe user mode. What is the user mode? So in this user mode, please, all user programs or applications, you can say user applications. Okay, applications are being executed in user mode, short form writing in user mode with preemptive manner, preemptive version or manner, version. Please understand, preemptive means so non-atomically. So this code will execute non-atomically. So non-atomically means preemption, preemptible, interruptible. So please understand. So this preemption, what if I say interruptibility, interruptible, in interruptible manner, interruptible manner. What does mean? Whenever user code is running in user mode, somebody can interrupt. So mean running program can temporarily can be stopped, then other program can run in CPU. Later point, this program can continue. So this is what preemption. So yesterday we discussed, last class we discussed. So from the last class, what was the discussion? So we distinguished the preemption and non-preemption. Can you recall what is the preemption, non-preemption? If I say non-preemption mode is running, so once the CPU once the CPU started executing with any particular process, the process will not release the CPU in middle by force. It can release only voluntarily. That's what non-preemption. Preemption means before completion only it can be preempted, forcefully deallocated. So preemptibility means what? So one program is running and CPU, so before completion you can take away, given to other process. Once that is over, again you can resume this interrupted process. That's what preemptible possible. Now, what is the conclusion? All user programs, all user applications running, executing, which mode? User mode. User mode only. Are you getting my point? Because since we are not privileged instruction, our programs are not privileged programs, so can be run user mode only with interruption. N number of times interruption can occur. When it comes to privileged instruction nothing but OS service codes, OS code, kernel code should run in a protected mode. Protected mode nothing but what? Kernel mode or system mode. I hope this point is clear. So this line is clear, all of you. So chalo, I'll write in the second one. What is second one? Second one is what? Kernel. Kernel mode. Okay. Kernel mode. Please understand the kernel mode. Okay. Kernel mode. So now see, I am writing operating system. Okay. Operating system service programs. service programs will say, or simply OS code, you can write OS code or OS programs, okay, OS programs, or you can say privileged, this also we can say privileged instructions, instructions are executed in kernel mode, with atomically. So what is the meaning of atomically? With atomical, nothing but, so no preemption. I hope you understand. No preemption, no interruption. Please understand, no interruption. When the OS service code is executing the kernel mode, so nobody will interrupt. No device, please understand, no interrupts will occur. The code is going to be executed atomic nature without any interruption. Once execution of the code is over in the kernel mode, then you shift into user mode. Then user mode can be run in a preemptible manner. I hope this is clear. The moment whenever OS code is to be run, so that will run in kernel mode only with protection. Nobody will interfere. What is the objective? Why? What is the objective of running the OS code in kernel mode? As mentioned, right? So nobody should interfere the OS code to corrupt it. So that will be protected. I hope this is clear. Yes, just respond. Yes, ma. Respond this point. What I am trying to say. Respond for this one. No, I need a response. So did you get it or not? Did you get it? So what is the difference between user and kernel mode? Okay. So now see, now we'll continue. Now we'll continue. What I'm trying to say now. Suppose example, I'll take some examples. Look at this example. Okay. Main. Okay. Int a comma b comma c, a equal to 10, b equal to 20, c equal to a plus b. Getting my point? So now I'm just marking print of %d comma c. So this I'm printing. So this is a program code. Whenever this you compile or execution, when you start execution, this entire code, please observe, this entire code will run in user mode only. So this entire code will run user mode of the CPU only. So what is user modes? Because this program is written by the user. What is the meaning of this program? Program simply taking some like ABC inputs, already assigned. Just calculate a plus b, throw print out, right? So print the C value. That's it. This program is written by me, so it should run in user mode only. If the program is written by the OS developer, OS code is there. The OS code is completely hidden things. We don't know. Like sometimes we use a OS routines, operating system routines we use in application. But whenever that routine is encountered, so that will jump from user mode to kernel mode for execution. So after execution, results will come back to the user mode only. Are you getting? Operating system is service. We take the service from the operating system, right? But service code will run in kernel mode only. But service code results will use in my application. But my application will run in user mode only. When my application running user mode, wherever you written a service code which is required to take from the operating system, you jump from user mode to kernel mode, take the service, again come back to the user mode. This will happen. Are you getting my point? So let's take an example. Sir, user application is there. MS Office is a user application. Yes or no? MS Office user application or not? User application. MS Office I open. Application I open. I'm using this application, right? I'm using application. Where this application will run? User mode only. But this application may require service from the operating system also. How, sir? Example that so doc is there, MS doc. Doc I want to print it. Some 10 pages file is I want to print it. The moment you print button, click it, some code of that application will run in user mode, but we require printer. To print a file, we need printer or not. Printer is a hardware component. Hardware component is completely under control of the operating system. Now means you understand this application need a service from the operating system what to use a printer. Now the application going to put a request to the operating system like through some interfaces. So I need a printer. Now operating system, the particular interface something, the particular code will run. So that will, the results will come out to user mode, but file get printed only. The printing is taken care by what? Operating system only, right? Yes or no? So for that some service code need to be run. I hope this is clear. I hope this is clear. Another example I will take it. Another example. We are working with a graphical user interface assumption. Graphical user interfaces we are working. So now in the graphical user somewhere you want to create a file. One file you want to create it. So what we do with the through mouse button new file something will select, right? So the moment new is created, you click on, what happened? Some file name you will enter, with this file space will come out or not, so that we can add data into file or not. But who is creating this file? Operating system. The moment you click on create something, so background some code for the create will run in operating system, right? It will run so that it will create a space for you so that you can add information. Now creating a file for you done by the operating system. But please understand now our user application, I am going to interact the operating system through some interfaces or system calls. The system calls will run in kernel mode that will create something to option to me so that you can add information that file. Am I right or not? Are you getting my point? So like such so many situations, all the things like whatever activity, whatever service you are getting through operating system, some kind of service code will run. Service code will run in kernel mode, so that service will take in. So service code we can access through system calls, please understand. Services of the operating system, user program or user application can access through system calls. Now system calls provides the interface between the programmer and operating system. System calls provides the interface between what? Programmer and operating system. Through system calls, we can obtain the service from the operating system. Clear? The statement is clear, all of you. The statement is clear. The first I told you, the CPU should run in two modes, user and kernel mode. What user mode will run, what kernel mode we understand. So why CPU has to run user mode, kernel mode also we understand, because we have to protect the operating system, right? Now initially all our user programs will run user mode only, but sometimes user program also requires service from the operating system. The particular service code only jumping from user to kernel mode and execute, so get the service from the operating system. This will happen. Yes or no? Yes or no? This is clear? Now I am marking the point. This entire code will run where? User mode of the CPU, user mode only. Now I am writing the point here. So very important point you can understand. Okay. So whenever a service, required from the operating system, whenever service required from the operating system, how to take the service? Via system calls. We get the service of the operating system through our system calls, via system calls. Whenever a service required from the operating system via system calls. So now I'm writing the transition. Okay. So transition must be made from user mode to kernel mode to obtain the service, from the operating system. So now what I am trying to say, normally our user programs will run user mode only. Whenever you want to take up service from the operating system, you have to put a request to the operating system through system calls. The system calls are available in the packages. Example, Win32 API, application program interface, having the set of system calls in Windows operating system. Similarly, POSIX API, application program interface, like especially if we talk Unix or Linux operating system, having set of system call. Through system calls, I can get a service from the operating system. Like like Java, if you take in a JVM, no, in a JVM app. So please understand JVM virtual. So Java virtual machine having set of API application program interfaces. So through which we can you can get the service from the operating system. The popular libraries are APIs here, application program interfaces are there, or we can call system call interface also, like Win32, POSIX, or so JVM. So through which we can access the system call. Through access system calls, we can get the service from the operating system. Is it clear now? This is clear, all of you. So what I am saying? Through system call, you jump user to kernel mode, then take the service here. So now, so this line is clear, all of you. This line is clear. Now very simple. Now suppose if I take, this is a main function, okay? Main function. Suppose some lines of code is there, like some lines of the code is there, assumption, okay? Some lines of the code is there, assumption. Let's take this is the complete this line of the code is to be run in user mode only, okay? So now I'm marking like, no, I'm just marking like this, okay? This is user mode, okay? User mode. CPU is activated in user mode only. Okay, now see, so this lines of the code is running in user mode. Okay, this lines of the code is running in what? User mode only. Let's take particular these two lines are there. Suppose the particular two lines are there. It is required getting the service, getting the service from OS. We need a service from operating system. So these are the system. Let's take assumption system calls. These are system call assumption. Now, whenever such things are encountered here, please understand. Whenever such things are encountered, now you have to shift from where to user mode to kernel mode. This is what? Kernel mode. Please observe. This is what? Kernel mode. So there is a option mode shift is the mode bits will be there. Okay. So mode bit is 0 indication user mode. So just 1 indication kernel mode. Right now when mode bit is 0, that means processor CPU in user mode, code is running user mode only. But in my program, some kind of system calls I placed. I want to obtain a service from the operating system. Whenever such system calls encounter, you have to change the mode from user mode to kernel mode. Okay. Now run this code. What is our code? The system call code you run. Once running is over, you have to return. You have to return from where? You have to return from where? You have to return from kernel mode to user mode. You have to return. Kernel mode to user mode, you have to return. I hope you understand my point, what I am trying to say. Simply my program or application running user mode only. In my application, some kind of service routines I kept. That system calls only. Because I want a service from the operating system. Whenever such routines or such system calls encounter, so those code is not available in my user mode. This code is not available in user mode. Just I use a caller function only, but details is not available. When such things are encountered, simply you jump, change the mode bit from user mode kernel mode, execute that routine, because the routine is going to be executed protectively in kernel mode. Without preemption, the code will run. Once the system call code is completed, then you will come back to user mode, continue the remaining part of the code in user mode only. This is a transmission will happen from user mode to kernel mode to user mode. Several times happens during any application or program execution. I hope this is clear. So what I distributed, all you kernel code will run here only. My all user program run here only. But user applications having the kernel calls also will are available. So because we need service, those calls only will run in kernel, will come back to user mode. This is clear? Yes. Please confirm so that I will show mode shifting process. I will show very clearly mode shifting process, how mode shifting will occur. So what are the steps, what are the things will happen during this mode shifting process. I will discuss. Is it clear or not? Till this point is clear? Till this point is clear? Respond. Yes, ma. Okay, chalo. So now, so far what I mentioned, this is a the situation where required to move from user to kernel mode. So thus this codes also I mentioned. Now let us see mode shifting process. Now let us see mode shifting process. Mode shifting process. So mode shifting, you can write in mode shifting. Put the heading mode shifting. Mode shifting from where? User mode to kernel mode. The first thing I am showing you, mode shifting. Okay, mode shifting. Okay. Okay. Now look how to this mode shifting occurs. Observe. So I am taking suppose main function. Let's say int a comma b comma c, a equal to 5, b equal to 10, c equal to a plus b. Okay, a plus b. Is it clear all of you? A plus b. So there is a function call. So function is there, assumption. Function is there. Now function prototype is here. Now see, function is there. The function definition I have written here. Let's take function definition written. Some I am printing. So print of some c value assumption regarding some return function. Return. So like this is the code is there. Okay. So this code is written by user. So this code is written by user. Please observe now. So this in a compiler time what? So the two things we know, compiler and runtime, both things you understand. Compiler time these variables are replaced like no will store in symbol table. Now runtime only this code will, because this is the assignment code. Yes or no? Assignment code only, right? Yes or no? So like we have to load this A, load B, then run. The function is called. This is a function. Which function ma? This function is what? User defined function only, because definition is available. It will jump to here. Yes or no? Whenever this function is encountered, jump to here or not? So this lines will run. This lines will run. Now your printf is encounter. The printf is predefined function or user defined function? Can you tell me? The printf and scanf are the predefined functions or user defined function? Please respond. What is this printf? Predefined or user defined? This is not defined by me. It is not user defined, right? So this is what? What is this? Predefined function. So predefined function. Okay, now see. Whenever this printf is encountered, it is jump to what? C library. Yes or no? So it jump to C library. It jumps to C library. Here some call is there. Printf. So printf call is there. This routine will run. Predefined. So this routine will run. So after running, this will come back to here. So I'll return from the function here. So remaining any part code is there will run. So this entire code will run where in user mode only. No requirement of shifting into kernel mode. I hope this is clear. C language is the, please tell me, C language is part of the operating system or not part of the operating system? Can you tell me? C language C library, this C library I said now, this is part of OS or not? Please understand, C is not part of operating system. It is independent. It is a plugin software. Yes or no? Plugin software. I can remove C. You can place C++. You can place Java. Correct. Plugin software I can remove. It's application software. Please observe. Application software to write the develop the programs. We write the code. We write the programs through the language. Printf is not system call. Yes, please notice. Printf is not system call. It's a predefined function. I said no function. Predefined. Who defined? Library defined. In a library, there is a definition for printer. So library, there is a definition for scanf. There is a definition for math. We use mathematical functions we use. Many mathematical power, SQRT, many functions we use. Those are all predefined functions which are part of the library. So language library, correct. Language itself no application program. So the C code will run where? User program only. It will run user application, please understand. It will run user application, user mode only will run. So printf, this function both will run user mode only. But you can ask me question. Sir, when I printf executed, whatever you define in this printf, that will be displayed on monitor. But monitor is a hardware component. hardware component under control of the operating system, but do we need system call or not? Yes, we need definitely system call. Please understand. As for the user point of view, see, as for the user code if you see, C library is a predefined programs which will run in user mode only. When these predefined functions are running during execution of printf program in user mode, now there internally one system call will be generated. It will be interacting with one system call called write system call, because we want to write the data on monitor. Whenever that write system call from the printf function is invoked, that moment will jump to kernel mode, will run that write system call, will come back again user mode. So remaining part of this one. But that part I am not worrying. But as you see the printf, if I mention, this is because from me the printf is what predefined only, but internally it will call. So that is secondary things. So printf is executed user mode only, that need to be considered. Clear? So now no requirement of the user kernel mode here when I am running it. So what I am trying to say now here, so any function you take, okay, functions. If I say function, nothing but this is a user, like user mode only will run. So these functions are of two types. One is what? User defined functions. I hope you understand user defined functions and predefined function. Predefined functions, okay. So both will run, please understand, both will run user mode only. Is it clear now? Is it clear? User mode only. So now please understand, whenever this user mode, this code predefined or user defined functions, when you compiled, please understand. So compiled, when you compiled, end of the compiled, these instructions are replaced by, so these instructions are replaced by branch save address, with some arguments. Please observe. I hope you are you getting my point? User defined and predefined functions, when you compiled, end up the point, because it is a function, right? Function address also required, where you define we don't know, right? So that's what end up the compile with replaced by branch save address BSA with some arguments. This is important line, I can mark it. So now another point. System calls. So system calls nothing but operating system service taker. This we get through system calls only, we get the service from the operating system. But the system calls are defined by what? Library. So like I said, Windows operating system library, so that APIs and Unix based, so JVM based will be there. Those system call definitions available in kernel code only. So now whenever system calls are encounter, I am writing encounter, please understand. Whenever system calls an encounter, when you compiled, please understand, which are replaced by, please, because compiler will not understand, right? What is system call will not understand because definition is not available. Simply it will replace by a privileged instruction, called, the privileged instruction called SVC. SVC means supervisory call. It is an instruction, please understand. So very simple, 2 lines only I am writing. Very simple line thing. 2 lines. What is the first line? User defined, predefined functions. Functions when they encounter, see, this function is encounter, right? Yes sir, this is a function is encounter. But this definition is available here, right? This definition is available here. So you have to branch to here. So what is the meaning? Branch save address, nothing but you have to branch to here, means you have to jump to this location. Jump to this location means this location address required. So that is taken for next modules. But I just saying the branch to here. Now see, whenever a printf is encounter, printf is a library call. You have to branch to where? Library function. You have to branch to library function. That's the reason you have to replace with BSA. Now, whenever such system calls, suppose I will give an example and detailed discussion will be there for system calls. As of now, just you look at system calls, something code will run in kernel part, OS code only, understand. Whenever such system calls are encounter, compiler will replaced by a privileged instruction call SVC. SVC is what? What is SVC? You write down. supervisory call. Supervisory call. Sir, why it is not replaced BSA? BSA if I say user mode only, I have to write it because user code only. But if I replace SVC, it should be resolved by the operating system, not by the user, because this system call code is available in what? OS code. So that should be resolved runtime only, not before time. So this point is clear. Now see next line. So now see the BSA address resolved. Okay. So resolved during linking time. During linking time. See now modules if you see, compiler, assembler, linker, loader will be there. Compiler, assembler, linker, loader will be there. So linking time. So branch save address will be resolved with original address where the function is available. Means function means what? Printf function where it is available in a library. So means in a library printf related code will be attached. Module will be attached. Now see function we are defined, the definition is there now. So this is a prototype. This is definition. This definition code is attached here. So this attachment done by the linker. Linker will resolve the BSA address. So the runtime. So runtime very simply, this function when I encounter the address will be there, it will jump to other address. So that code will run. Whenever printf is encountered in runtime, so the address are already attached by the linker. You jump to that particular code, you run it. So this will run in user mode only. But no, whenever this privilege, like whenever system call is encounter, replaced by privilege instruction SVC is the instruction. So instruction should be run. During runtime what happens we'll observe. Just conclude me, respond me. Did you understand the steps which I mentioned so far? So from this mode shifting as I mentioned, very simple things. Normal code I given, this code will run in user mode only. But what is the conclusion? There wherever you define user defined or predefined will run in user mode only. But they when you compiled it, replaced by BSA, because that will be resolved by the linker only, because as of now I don't know where they are. So that's a BSA. BSA will resolve or given original address during linking time only. But another thing I am telling, when system call is encountered, replaced by supervisory call is a instruction. This instruction will resolve at runtime. Is it clear? Is it clear all of you? Is it clear? Respond. Then further steps I'll give it. Yes, everybody respond. Now look at the point. Now here is again I'm taking the examples. Int a comma b comma c. So a equal to 10, b equal to 5, c equal to a plus b. Okay, a plus b. So printf percentage d comma c. Okay, so this I written. Okay, followed by function, followed by fork is there, some lines of the code is available. Now this function definition, the function definition is here. Okay, written. Okay, this is there, assumption. Look at this code here. Okay, now see, I want to execute this code here. So compile time only, this will be replaced. Now this is the instruction, I will load, runtime I'll execute. Now see, compiler time, what I said you, the printf, right? Printf is a predefined function, is library call, it is replaced by BSA, branch save address. Yes or no? Because now function is there, some function. So this function definition available, right? So this also replaced by BSA. Getting my? Now see here fork I mentioned. As of now, see, I am giving the list. Compiler will decide whether it is system call or not. That knowledge will be there. Now fork is a system call. Whenever system is calling encounter, we are replaced by SVC. What is SVC? Supervisory call. So end of the compiler, this work will happen. Predefined function, user defined functions are replaced by branch save address, and the fork system calls replaced by SVC. This is done. Sir, you can ask me a question, how you come to know, sir, this fork is a system call? That's what, that must, knowledge should be there. It is a fork is a Unix based system call. We'll observe what is the fork later. As of now, this is a system call. This code is not, I don't know the code of the fork. Code of the fork is available in kernel part. OS code only is available. So this has to run in kernel mode only. Now till this one, now so compilation override. So now assembly language done, then linking time. So linker and loader will be there. Link time what happens? Now see, so now printf, right, this BSA replaced by, please understand. Now BSA replaced by X address. In X address, in a code will be attached. X address, this code will be there, you can run it. So function is replaceable, let's take Y address. Let's take Y address. In a Y address in the memory, code for a function is available, you run it. You're getting mad? But SVC not replaced, keeping as stage SVC only. SVC only. Now this code will run. So this code will run. Okay. So now see, there are two things I mentioned now. This code will run. Okay. So this code will run. So I'm taking here runtime. Okay. Look at runtime. Okay. Look at runtime. Okay. Now see. Now from this one. So now here from, so this line, please observe. So now, so this line of the code I will run. Okay. So the printf function, code already available, jump to that library, it will run. So this function is there, it will jump to here, it will run. Okay. Now till this point, please observe, till this point, okay, till this point I'm marking. So code will run in user mode only. Code will run in user mode only. Clear? Code will run in user mode only. So now whenever, please observe, whenever this fork is encounter, the fork you have to run in what? Kernel mode. So now first of all, what is going to encounter? First SVC going to be encounter. So I am writing now. SVC is encounter. Okay. SVC is encountered during runtime. Okay. So now please understand now. SVC encounter means SVC executes, right? SVC is a instruction. Yes or no? SVC is an instruction. Which instructions are? It's a privileged instruction. So SVC will run. So SVC runs. Okay, please observe now. Whenever SVC instruction you run, the next step will be, please understand, some software interrupt is generated. Please observe. Clear ma? Point is clear? Runtime point you understand. Runtime, this code will run printf, wherever definition available, printf definition go to like X location you run, and function definition available go to Y location. This is at Y location will run. Then SVC encounter, when it encounter during runtime, SVC instruction will execute. Execution instruction means what? Generate the software interrupt. So there are three types of interrupts will be there. Please understand, three types of interrupts: software interrupt, hardware interrupt, internal interrupt. Hardware interrupt generally comes, the interrupts from the hardware devices. Please, this also we call external interrupts. We call external interrupts, nothing but interrupts comes from the hardware devices. Let's say some printer, let's say some monitor, some devices want to transfer data. So those are external interrupts. Internal interrupts are errors like stack overflow, divisible by 0, infinite events. So such cases internal interrupts comes. Software interrupt is a privilege, like it will come from the execution of privilege instruction, saying that software interrupt results is you have to shift the mode from user mode to kernel mode. So that you need to understand. For every interrupt, next step I am writing, no? For every interrupt, whenever any interrupt occur, please understand. So whenever any interrupt is occurred, whenever interrupt is occurred, okay. So current program execution will stop, end of the instruction cycle. Now you have to run. So now you have to run what? ISR. What you have to run? ISR. What is ISR? Can you tell me? Can you tell me what is ISR? ISR is what? Interrupt service routine, ma'am. Interrupt service routine. ISR. Okay. Meaning what? Whether internal interrupt, external interrupt, software interrupt, whatever interrupts comes, dealing with this interrupt nothing but you have to run the ISR. What is ISR? Means example. Let's take example. Is a CPU running. So there is some interrupts comes from the device saying that I want to transfer the data from disk to memory. So whenever interrupts comes, I have to service the request, right? I have to service the request, nothing but I have to run the relevant ISR for that, so that I am servicing that interrupt. I hope you clear. I hope you understand. Now interrupt encounter is occur nothing but relevant interrupt ISR you have to run. ISR you run. Please understand. So this execution of ISR will be two things, ma'am. Please understand. Execution of ISR happens two functions. Happens in two functions. Please understand. Execution of, please, are you getting my point? Execution of ISR means routine you have to run. So execution of ISR, nothing but two things will happen. What are two things? First one, mode bit change. So read the mode bit change, user mode to kernel mode you have to change. Read the process status word register. Read the process status word register and change mode bit. Change the mode bit. Okay. So change the mode bit. First function. The second function is that read the dispatch table. So we change, right? So change the mode bit, nothing, you jumped into kernel mode only. So now you have to read the dispatch table. For what? For address. For what? Address of the fork system call. For what? For address of the fork system call. So this is the point you have to understand. The step is clear? Please tell me, this step is clear or not? Yes, ma, tell me, this step is clear. I'll continue now. So now read the, like I said, read the process status word. Now I'm telling you, here I'm writing. So process status word is a register. Okay. So register which contain all flag information, right? Which contain what? Flag information. So like, you understand it's containing, so overflow, carry, JAD bit, like apart from this also has lastly as a mode bit. Let's take, process status word is a register. Okay. So much other information will be there here. Okay. So lastly, here is this is a mode bit, ma'am. Mode bit indication, CPU mode bit. Currently 0, nothing but what? So I'm marking here mode bit. Okay. Mode bit 0 and 1. 0 indication user mode. 1 indication kernel mode. Okay. Currently what? 0. So now 0 you have to modify to 1. Okay. 0 you have to modify to 1. Meaning you shifted from your user mode to kernel mode. Now CPU started executing in kernel mode. Now CPU is going to be executed without preemption. Protected. It is running in a protected mode here. Now please understand, whenever you change the mode bit from user mode to kernel mode, so now currently executing process would be there, that get blocked. Whatever CPU doing normal execution, right? So that normal execution is CPU was doing. So now due to shifting normal program, you have to stop, block it. Then you jump to kernel mode. Now immediately what you have to read it. So what I said, what second step, what I said you, read the dispatch table. This is the first thing happened, right? What is second thing? So anyway, I marked here. So now see, what is second thing? Read the dispatch table. So in the what I said, dispatch table. So I can mark it here. I'll use here. So dispatch table. So read the dispatch table. Sir, what is the dispatch table, sir? Please understand, as I mentioned, operating system contains the list of operating system contains, please understand, list of system calls and their address, ma'am. Please observe. Let's take read system call is there. Read system call. Let's take this address is like this. Let's take P. So now write system call is there. Write system call Q. Let's take open system call is there. Open system call R. Getting my close system call is there. Close. Let's take PQR S. Like this, somewhere fork system call will be there. Fork system call. So this address, let's take X is there. X. Like list of system calls and their addresses will be there. Addresses nothing but what is address? In this X address, please understand, the fork, please understand, fork definition is available. So fork definition is available. Fork definition is available like this, understand. Now what is steps? What is step number one? What is step number one? First you change the mode from where? User to kernel mode. Then read the dispatch table. In that dispatch table, concern system call, look at the address. So address is what? X. This address is what? X. So this address X you have to place into program counter. So program counter you place X. So when you place X in program counter, now see, program control will pass to where? The program control will pass to where? Fork execution or not? Yes or no? So previously program counter value something. Now when you place as X is X in program counter, now execution goes to, no, execution will pass control to here. So can I run the code of the fork or not? Tell me. So can I run the fork of the code or not? Yes or no? Now execution of the fork code will happen protection without preemption. Without preemption, this code will run. This code will run. Okay. So once the code will complete, have to go back to where? Have to go back to where? Again user mode or not? How to go? How to go? Again every system call, end part, supervisory call will be there. Again supervisory call will be there. Okay. Now reverse process, returning. Okay. So return from kernel mode to user mode. What happens? What happens? I said the every system call has SVC instruction at end part of the program, end part. Okay. Now when you run SVC, what happens? Software interrupt will generate or not? Software interrupt generate or not? So when a software interrupt generate, you have to run ISR or not? You have to run ISR. What ISR has to do? ISR has to do what? ISR has to read the process status word and change mode bit. Change mode bit from where? Mode bit equal to 1, currently 1. You have to change 0. Then you are jumping into where? So you jumping into where? User mode only. So continue the code. These are the steps happens. I hope this is clear. Yes, I'll give the short framework, but to understand the steps, what I'm simply telling. User programs, user application run user mode only, kernel code will run kernel mode only. Many times user application or user program used to get the service from the operating system via system calls. So user application program use the system calls. So normal code will run user mode. When a system calls are encountered, it will run in kernel mode. How it will run? Mode shifting process I said. Whenever a system call is encountered in compile time, replaced by SVC supervisor call. When you run this code, SVC instruction, software interrupt generates. Its results you have to run the ISR. ISR when you run, two things will run. One is first thing, change the mode bit by reading the process status word. Change from user to kernel mode. Immediately you are in kernel mode, block the current process. Now read the dispatch table, look at the concern fork system call, and look at the address you place in program counter, so that program control pass to the fork system call to be run. It will run one by one. When you run the fork system call, the preemption will not happen. Nobody will interrupt till its completion. Once completed, then you have to return. Again, you run the SVC will generate a software interrupt. So software interrupt encounter, you have to run ISR. ISR means you have to change the mode bit, only process status word. Change from 1 to 0, then you are in a user mode. So remaining code you can run it. Yeah, just tell me, is it clear? The process is clear. This happens all today. Whatever you are doing now, whatever activity you do on your operating system, this will happen. Yes, this is going to happen. Yes, ma, tell me. So did you understand or not? Everyone, kindly respond. Okay, please copy da. Did you copy these things? So please from here you can copy. So main code, this is the user predefined are replaced by here BSA, then yes, fork is by SVC. Runtime, this before runtime, link time only, BS are replaced by original addresses or relative address of those functions, but SVC is not replaced. When you running runtime SVC run, it will generate the software interrupt. Correct. Please copy. Then this one, so interrupt is occurred, software interrupt, then ISR will run. Execution of ISR will be two things: read the process status for register and change the mode bit, and read the dispatch table for address to get the address of the fork system call. Done. Now, see process status for register is the mode bit is there, you have to change 0 to 1, we shifting from user mode to kernel mode. Then, so dispatch table contain list of system calls, you can take a screenshot and their addresses will be there. So look at so address of the fork X, in the X address code will be there. In X address nothing but kernel part, see memory also divided into two parts, right? OS code and kernel code. In a OS memory area, X location, the code will be there. You are jumping into that code, you start running. Once execution over, again you have to run the SVC supervisory call. So supervisory call, again what happens? Generate the software interrupt, run ISR, change the mode bit in a process status for jumping into user mode. So now just this framework I am now making so clear. So what I am trying to say here, I am marking steps. The simple steps I can mark whenever system call, okay. So system call encounters. So this system call is replaced by SVC supervisory call, yes or no? When you run this SVC, software interrupts generates interrupt, yes or no? Software interrupt will generate. So software interrupt generation nothing but you have to run ISR. What is ISR? ISR is what? Interrupt service routine. So what I said you? So this will do two activity, yes or no? This will do two activity. I will mark it like this, okay. What is the step number 1? Step number 1, process status word, process status word, okay. This is the process status word. Mode bit, okay, mode bit, you have to change 0 to 1, okay, 0 to 1, this is the mode bit. Change the mode bit. What is second step? Second step is what? Read dispatch table, So I am reading like this, somewhere fork will be there. This address, let's take I address, okay, I address will be there, okay. So now, so in a program counter, okay, you have to place it I. Getting my point? You have to place it I. Are you getting? You have to place it I. So in I location, fork will run. So fork code will be there. So end of the fork code SVC will be there, right? You have to run this code. Whenever again SVC is encounter, what happens? Whenever SVC encounter, then what happens? Software interrupt interrupt will generate. Whenever the software interrupt generates, ISR will run. Again, ISR will run. ISR meaning what? You have to change the mode bit here, 1 to 0. That's it. So these are the steps. I started here. I just I come here. This is the flow of execution of what I can say shifting process, mode shifting process. You can say system call, replace SVC, run software interrupt, execute the routine. Two things: change the mode bit, read the dispatch table, place the address and program counter, control process to this location, run the particular system call. Once over, end of the time, you again execute the SVC that will generate a software interrupt. Go run the ISR, change the mode bit, the process status word. I hope this steps, simple steps is clear. Yes, all of you more. Respond. Just copy. Copied ma? Okay. Chalo. Now, so far we are talking system calls, right? So we are talking system call. So now let us understand what is the system call. Put that in. Put that in system calls. System calls. Put that in system calls. Write down. System calls are the extended instructions. Extended instructions. Instructions are interface programs. You understand? Otherwise, interface programs. Extended instructions are interface programs. Okay. So that provides simply interface between user programs and operating system. This line I can say this user program here is operating system. Understand? Now this please, these are the system calls. The system calls provides interface between programs and operating system. Yes or no? That's one. Write system call, read system call, open system call, whatever you use, that's interface to operating system only. We'll take service from the operating system through system calls only. So now, what I'm saying, all operating system services can be obtained through system calls only. Please understand. So types of system calls. Types of system calls and number of system calls. Number of system calls will vary. Varies from operating system to operating system. Types of system calls and number of system calls will vary from operating system to operating system. So major classification, major types if you observe, first one is program control system call. Program control system calls. The second one is file system manipulation, file management, I can simply file management system calls. Third one, device management. device management system calls. The fourth one, communication related system calls. The fifth one, information maintenance system calls. Clear? What are the major classification of system calls? Program control, file management, device management, communication and information maintenance. The major 5 classification of system calls which we can observe in various operating system. It can be a Windows, it can be a Linux or Unix, other operating system. Clear? Is it clear, ma? Now see, if I take the program control instructions, program control system calls. Program control system calls, please understand. Through this system calls, we can execute the programs. I want to execute the program. So execution of programs required some kind of system calls to be run. Meaning what? Understand. So I have to create a file. I have to create a program, right? Create a process. Create process. So once you create the end of the program, so end this you can end it, or you can middle abort it. You can abort it. Getting my point? Are you getting my point? So you can schedule or execute this program. Execute, load this program. Getting my point? Set attributes, some attributes for a program. Set attributes. So what are the attributes of a program generally? Program like process name, process number, process size, process type. The various process related attributes we can set it. So whenever you want to read it, get attributes. So get attributes of a process or program. So these are a general, like even more. So these are the types to understand or set of system calls through which we can run our programs. Create a process, load the process, allocate, say I can write even allocate memory. We need to allocate the memory also, right? Allocate the memory to the process. Once execution over, free up this memory. Like this all comes under program control system calls. Clear, ma? So now just note of it. Create, end, abort, execute, load, set attribute, get attributes, allocate memory, deallocate the memory for a program. So next, what second one I said? File related, file management related. So first of all, you have to create a file, right? Yes or no? This now example you see, creating a file you might have observed through graphical user interface, character user interface, even programmer also can create a file also, through programming also, right? Through programming also can create a file. Graphical user simply, so I can use a mouse pointer, I can create it. But internally one system call will run. When you run the system call, then only you will get a file with a name, whatever you mention, and space get, so that you can add information, right? Create a file. You can open this file, open this file. You can close this file. You can delete this file. Getting my point? Delete this file. So read, write, modify. There's many will be. This all comes under file management. You're dealing with the files. So whatever operation you do on file through system calls only. You can do it. Yes. See, user means there are two things, user and programmer. Programmer also uses system call, user also uses system call. User using system call through two variations. One is graphical user interface, one is character user interface. Let's take example. So you are sitting in front of the computer, you systems turn on the computer. One file you are opening, by clicking the mouse you are open the file or not. Opening is nothing but a system call, right? How the application get ready? Open. Yes or no? You are closing file, you are deleting file, you are adding something information, you are removing file. Are you doing or not through mouse and keyboard? So this nothing but user, you are interacting the operating through what? System calls only. Yes or no? What is the programmer? Programming you write, creating a file, adding a data into file. Through programmer also, that also system calls will be there. Say yes or no? Yes or no? Respond ma? Respond. Yes, yes. The third one. So device related system calls. Device management. Device management. Please understand. Okay. So devices, please, especially IO devices. The request and release, request and release through we can access. First, I want to use any device, you have to request. So request device, and after using release this device. Release, you are performing a read operation, read, you are performing the write operation. So reposition, so this, and again set the device attribute, get the device attributes. Setting the device attributes, getting the device attributes comes under device related device management system calls. Clear? Now fourth one. What is the fourth one I said? Communication. As I mentioned, as a service, operating system, one of the major service, what I said, it is creating the beautiful environment where processes can communicate each other by transferring information or sharing of information. Getting? So now the communication means what? You have to establish the communication between the processes or not. So create or delete. So delete communication connection. Communication connection. So once you establish the connection between the process, you can send the data. You can send the data, you can receive the data between them. Through what? Suppose synchronization, like primitives, if you use pipe. Through pipe we can establish the connection. So we can send and receive the data. And check the status. Check the status, store in the buffer. These are related to what? Communication related. The fifth one I said what? What is fifth one? Information maintenance. We store the information, we maintain that also. Information maintenance what? Setting the data, setting what? Date. Date for a particular file or time. Setting date or a time. So whenever you want to read the system date, time. So date or time. Get any kind of attributes of a process. So I want to know, so details of a process, that all comes under information maintenance. Clear? These are the types of system calls available. What I want to conclude here, all of you please understand, whatever activity you do on operating system, and operating system giving the service, you are accessing the getting service from the operating system via system calls only. The system calls are the interface programs. Their definitions available in operating system code, which is not defined by me, defined by the OS only. They will run in kernel mode. Kernel mode is protected mode. Only OS code only will run. User mode is what? Unprotected mode. So that user application will run. Our application can be preempted any point of time, n number of times can be preempted, but OS code is not going to be preempted. You observe yourself, whenever you something you are writing, like using the computer, sometimes system is not allowed to close it. It has, the function should complete, then only other activity you can do it. Yes or no? So those activities done in kernel mode only. I hope you understand the the entire process of shifting the modes, different modes, why it is required, how they move here and there, for the purpose, the flow, everything we discussed. We also understand what is system call. System call and type of system call we have seen. Then one case study we can discuss in the next class. Case study on system calls is as I mentioned, fork system call. So it required time, actually is required time. So because this comes under program control system call, which generally available in Unix or so Linux operating system. Linux operating system will understand detailed study with C and fork, because in the gate examination point of view, The fork is important many times. So I saw the questions on fork system column. Better we'll make a separate session on the fork. We'll understand, we'll see the problems on this area also. Clear? Is it clear? Respond ma. I hope this session definitely useful to you, because lot of understanding also we have seen, like if we want to implement multi-program operating system, what hardware support required, how they do. This observation we did. Right. Respond ma, respond. So now I'll be continuing this session into the schedule already I mentioned. So in that next session only we'll see, but so there will slight change in the schedule due to some unavoidable circumstances. So as per the schedule, today's 8th, 9th, 10th and 11th class schedule is there, but I'm just postponing into I'll be taking 13th or 14th. I'll be as you can get the notification. Due to unavoidable circumstance, 2-3 days I'm postponing session, otherwise I'll continue only. So I hope you understand the point. Okay, we stay connected to this channel so that definitely you will get the beneficial content. Fine. Thank you so much.